Hello, and welcome to this fourth podcast brought to you by the Vatican Observatory Foundation. I'm your host, Bob Tremblay. Joining us today is Dr. Daniel Britt, Brother Bob Macke, and Brother Guy Consolmagno. I'll let our guests introduce themselves, starting with Dr. Britt.
Well, thanks, Bob. My name is Dan Britt. I'm a Pegasus Professor of Astronomy and Planetary Science at the University of Central Florida. I work primarily on asteroids, the Moon, and Mars.
Okay, Brother Bob.
Hi, I'm Brother Bob Macke. I am the curator of meteorites at the Vatican Observatory. I've been here since 2013, and I study meteorite physical properties, density, porosity, magnetic susceptibility, and thermal properties.
And finally, Brother Guy.
I'm the director of the Vatican Observatory and president of the Vatican Observatory Foundation, a planetary scientist. And back in the days when I was doing research at the University of Arizona with the Vatican Observatory, I met Dan Britt. We discovered we had a lot of interests in common and a lot of places where we could collaborate. And out of that collaboration, I introduced him to Brother Bob Macke. So I'm the reason that those two guys are on this podcast together and working with each other.
Our first topic is, what's the history of the Vatican Observatory with the space programs of the 20th century?
Well, the first one that comes to my mind is the director, several directors before me, George Coyne. He was named the director in the late 1970s, but he was an astronomer getting his PhD in the 60s, knowing a lot of people in the DC area, and he was fascinated with science and space, as all of us were. And he applied to be an astronaut. Now, in the Jesuits, you can't just do these things on your own. You have to get permission from your superior, because we take this vow called the vow of obedience, and that allows the superiors to assign people where they think are, most useful. It's kind of like the military that way. So he went to his provincial, the guy he needed permission from, to see if he could get permission to apply to be an astronaut. And the provincial looked very seriously at him and rubbed his chin, and he said, "George, if I let you be an astronaut, everybody's going to want to be an astronaut." Fortunately, he had his tongue firmly in his cheek at that point and gave George permission to do this. George went through several layers before one of the doctors looked and said, "How long have you been wearing glasses?" And George goes, "I always wear glasses." And that was enough to get him booted out of the system.
Oh, that's unfortunate. I wear glasses. But actually, the history goes a little bit earlier than that, because if you recall, on over Christmas weekend of 1968, the Apollo 8 mission orbited the moon, the first mission to orbit another body around the solar system. And then those astronauts returned to the Earth, and less than 2 months later, Frank Borman made a visit to the Vatican Observatory and signed our guest book. One of my hobbies is our guest book and studying the visitors that we've had in the past, and that is definitely one of the more notable ones. Also, another visitor on the day of the Apollo 11 landing on the moon with Neil Armstrong and Buzz Aldrin, Pope Paul VI came to visit to watch the lunar landing from our domes on television. And then from there, he gave an address greeting the astronauts and blessing their efforts.
A couple other times, popes have spoken to astronauts in space. Both Pope Benedict and Pope Francis have done that. And we have been consulted to say, can you think of anything the Pope might want to say? Or we've had a sort of an informal sense that way as well. It's funny, I've been in the planetary science business for nearly 50 years now. I started at MIT in 1971 in Earth and Planetary Science, and was quickly brought into an undergraduate research program involving planetary science. As I was looking for an undergraduate program to do, there was a Professor Macke who said, oh, you're young and eager. There's going to be this lander on Mars later in this decade, and you can be the one who looks at all of the maps and choose where the Viking lander is going to land. And I'm thinking, you're nuts. They're not going to let me do that. So I went and found somebody else to work for, which was John Lewis. Through a long and personal history, it had nothing to do with me, the Jesuits, or the Vatican. I have succeeded in never being associated with any spacecraft mission, which is probably unique for someone who's been in the field as long as me. And so you'd think that, with no budget for space and, no personal connections to be involved in a space program, there wouldn't be any kind of space programs being planned at the Vatican Observatory. But that's not exactly what has happened.
So how have Vatican astronomers gotten involved with NASA missions?
I think, Dan, you're the one to help us out on this because
That's your cue.
Oh, it is. Okay.
it's your fault.
All right. Well, I've been involved in 4 NASA missions. I was on Mars Pathfinder and Deep Space One. Mars Pathfinder obviously went to Mars. Deep Space One was a flyby of a comet and an asteroid. Those are done. I'm currently on the New Horizons mission that's flying into the Kuiper Belt, and also on the Lucy mission, which is going to fly by 5 asteroids in the Trojan Swarm. What we also do is we work on the physical properties of meteorites. So more immediately, Bob is probably the leading researcher in the physical properties of meteorites and how they're put together and how, therefore, asteroid surfaces respond to things like getting whacked or whacking into the Earth. And NASA is bringing back some samples on the OSIRIS-REx mission, samples from an asteroid. And it looks like Bob will get involved in doing some of the physical properties work with those. Somewhat longer time horizon, the Lucy mission is one of these things. The Trojan asteroids are out in Jupiter, and it takes a long time to get to Jupiter. And so the Lucy mission is actually going to be going on until 2033. And I'm going to be really old by then. So what they had hired me to do in the Lucy mission was essentially look at physical properties of these objects. And so it only made sense to find somebody younger who would still be interested in actually working on these things and burning the midnight oil. When I
might still have a job then.
And so I invited Bob to come along and work with me on this. In order to be on a NASA mission, you have to have the approval of the principal investigator and NASA itself. And they were happy to approve Bob because the Vatican Observatory pays him whether he does this stuff or not. And so they said, well, that way we can stop paying you and we can keep the money ourselves.
Now, I want to point out.
To be fair, they don't actually pay me.
Yeah. Well, they support you.
Yeah, I do want to confirm what Dan said, that it's without question that Bob is one of the 5 best people in measuring physical properties of meteorites in the world, since I think there are only 4 of them.
And that actually is what prompted potential involvement with the OSIRIS-REx mission, bringing stuff back from Bennu. The person on the mission who was charged with preparing to measure physical properties of the specimens that they have collected was looking around going, who do I know who can do this? Oh, let me call up some people.
I want to come back to Dan, though, because there are a couple of stories about your involvement in space missions, which I think are fabulous. First, to go to Mars Pathfinder, you were the image scientist on IMP. Am I remembering that correctly?
Yeah, I was the project manager for the imager for Mars Pathfinder, IMP.
Now, that was not the cute little rover. That was the thing taking pictures of the cute little rover.
Yeah, that was the thing that actually made the cute little rover famous. Was we had pictures of it cuddling up to rocks.
As I recall, those rocks were given informal names. How did that happen?
That was kind of my fault also, because you didn't want to say go to the third rock on the left from where you are right now. And so instead of giving them hard to remember numerical names like rock number 1, 2, 3, we gave them nicknames. And so you had rock called Barnacle Bill and rock called Spud and rock called
Yogi,
yeah. And that was one of the nice benefits, was if you were on the science team, you got to name rocks. And so I named them after my uncle. Spud was after my uncle. That was his nickname. Cartoon characters. My son called up and wanted to name a rock after his favorite character. So there's a Scooby-Doo rock.
How did the Cartoon Network deal with that?
Yeah, well, actually, if it would have been Disney, they probably would have sent their attorneys, but instead they sent T-shirts. They thought it was a great deal. And so I have a Barnacle Bill Scooby-Doo T-shirt from Cartoon Network that, they sent 100 of them over to JPL. That was great.
Your son was 5 years old at the time, I think?
Something like that, yeah.
Where is he now?
He's working for Ball Aerospace, doing space projects.
Fantastic. Okay, and the next mission was the mission to to a comet.
Yeah, we flew by Comet Borrelli.
And I'll tell a story there because one of the engineers on that, as I recall, the navigation camera died en route. And they needed a camera to be able to orient the spacecraft and know which way they were going. And a friend of mine, Steve Collins, who is known as the hippie NASA guy because he's got long hair, and he's actually a friend of Bob Tremblay's as well because we belong to the same science fiction club. But he was a JPL engineer who worked out how to use the science camera as a navigation camera and, help save you guys bacon. It's a small world. We tend to all know each other.
So true.
But you've also been involved in missions that didn't happen. Have you ever tried, Dan, developing a mission of your own?
This has been a recurring trial of Sisyphus for me. One of the things that you have in NASA is as a scientist, you have the opportunity to develop and lead your own space mission. And if you can write this proposal, and if your proposal is successful, NASA will give you $500 million or $1 billion to go off and fly your own mission. It requires a lot of effort by a lot of people. And typically you need to get involved, get NASA centers involved, get major defense contractors involved. And so here you're this young scientist going around talking to big defense contractors, talking about hundreds of millions of dollars of business for them. And so it's really strange. I remember negotiating with Lockheed Martin about launchers. This particular project went nowhere, but they were going to be using used ICBMs, surplus Titans, and they were selling them. And I said, well, I need 4, but I'll pay for 3, and you have to give me the 4th one free. And they agreed to do it. But that proposal never went anywhere. Another time, I was visiting Guy at the Vatican Observatory, and I was in one of the visiting scientists' office.
This was back in the days when we were still in the Papal Palace.
Yeah. So every evening, I would go to that office and have a long telephone conference with my engineers. And I was working with the Applied Physics Laboratory back then in Maryland. And some of the engineers were kind of hard to get along with. They thought I had a great idea. And one of the things that I should do is fire everybody else on the team and just rely entirely on them. And I was a little bit suspicious of their motives. And so they had several days of increasing arguments.
So what time of the day would this have been in Rome if this was daytime in Maryland?
Well, I would start at about 7 p.m. in Rome, and this would go to 8:30 or 9. So not hugely late, but it was nighttime. One of the characteristics of the Papal Palace in Rome is it's not air-conditioned, except by very thick walls, and no screens on the windows, so the windows are wide open. And there was one evening where we were in very heated discussion over some topics, and I said a few things that I generally don't say in telecons. And the person on the other end said a few things that probably he shouldn't have. And I was doing this loudly. And in the middle of this conversation, one of the Swiss guards comes into my office. He holds his finger to his lips, says, shh, and points out my open window, which is directly above the Pope's bedchamber. And this was John Paul II. So a saint told me to shut up. Then a Swiss guard to tell me to shut up. And I said, at a much calmer voice, I said to the guy on the other end of the line, do you know what just happened because of you? We have an interesting time visiting the Vatican Observatory.
Yeah, you and your family have been there a number of times. I've seen the kids grow up from when Devin was an infant to, of course, now he's well into his 20s. I won't say what that says about the aging of you and I.
That's the reason I need Bob to take over in Lucy.
Exactly.
Well, all I know is when I arrived at the observatory, Brother Guy kept reminding me over and over and over again that I was born the year that he graduated from MIT.
Indeed. And now you're encountering people who were born the year you graduated from MIT. So
or after, yes.
life goes on.
I heard mention of the OSIRIS-REx mission. Do Vatican astronomers have roles in any other NASA missions, current or upcoming?
Dan mentioned the Lucy mission earlier, and I am associated with the Lucy mission at the moment through Dan. At the moment, I think that's all that we have. Now, curiously, there's a spacecraft with an instrument that is named after a Jesuit who's from one of the earlier iterations of the Vatican Observatory. It's the Stereo spacecraft, which is a solar observing spacecraft, has an instrument called the Sun-Earth Connection Coronal and Heliospheric Investigator, or something to that effect, which, if you spell out the acronym, is SECI, which is named after Angelo Secchi, who is one of the pioneers of astrophysics. He was the director of the observatory of the Collegio Romano back in the mid-19th century. One of our best scientists.
I have to admit, you made that video about Secchi, and when I watched that, I was sitting here, okay, went to Catholic school, Catholic grade school, Catholic high school, was in the choir, right? I heard nothing about Secchi or any contributions to science by any Jesuits whatsoever, and that kind of makes me upset. I'm really glad that we're starting to do a push and can get the word out.
There's a couple of other places that we've got associated affiliation with science. For instance, Dan mentioned how if you have an idea for a spacecraft mission, you can get some startup money, you can go try to put the mission together. When you've got a proposal that's ready, you submit it for the $500 million or $1 billion, whatever it is. Those proposals have to go before a committee. And in the mid-aughts, I was one of the members of one of these NASA committees looking at 5 different proposals to get essentially $1 billion. In those days, everybody thought that going to the moon was going to be NASA's priority. So there were 2 different proposals to go to the moon. And we sort of assumed that the fix was in, one of these moon missions would get it. And there were a couple of other really interesting missions. I was actually in charge of doing the careful analysis of the science, not of the engineering, just of the science of one of the missions, which, since it wasn't selected, I won't talk about it anymore. The mission that did get selected, which all 5 of us thought was the best mission, was the idea of sending a microwave telescope in orbit around Jupiter. And we said, of course, of the 2 moon missions, we know you're going to choose one of them. This is the one we prefer. But actually, you really ought to take a look at this Juno mission. And lo and behold, that's the mission that NASA chose. And it's been a fantastic mission. But I'll tell one interesting story. As I say, members of the team that chose which was the mission scientifically we thought was the best, there would be certain members who were in charge of running the analysis of the science of a particular mission. And there was a guy named Paul Steffes, who was on our committee, who was in charge of looking into the science of the Juno mission. And Paul has an interesting connection with the Vatican in this. When I first ran into Paul, he said to me, "Hi, Guy, do you remember me?" And I'm going, "Remember you? I have never met you before in my life." And he goes, "We were in high school together." But of course, he was 2 years behind me in high school. So how could I ever remember? If I'm a lordly senior and he's a sophomore, surely I'm not going to pay attention to him. We were at MIT together. Our fathers worked together at Chrysler Corporation. While we were at MIT, we both dated the same girl, which fortunately neither of us married. He's happily married, and I'm happy where I am now. But he was always 2 years behind me, and I had never known this connection until finally I ran into him. It turns out his expertise, I just have to end with this story about him. His expertise is in making microwave observations of hot chemicals like you might find in the interior of Jupiter. And he has a lab at Georgia Tech with a giant container, about the size of a room, made out of stainless steel that has 1,000-degree hot hydrogen and other nasty gases. And they let him build this lab on the roof of the skyscraper. Every skyscraper has this cement pillar that usually you put the crane on, and then you build the skyscraper with the crane on this pillar. On that pillar is his lab now, so that when it explodes, not if, but when, it won't take down the entire building. The other thing I'll mention in just, personal connections, as I said, we all know each other, is that the OSIRIS-REx mission was originally proposed by Mike Drake. I was Mike Drake's first graduate student. After Mike died, sadly, much too young, he was taken over by his number 2, a fellow named Dante Loretta. And Dante had been the grad student of a classmate of mine at MIT. So when you see a mission, when someone in our field sees these mission, we immediately identify the people doing it, their strengths, their weaknesses. You'll say, why was that guy put on the mission? Or, ooh, this is going to be good. This guy's really good.
You mentioned Dante. I knew him when he was a grad student at Washington University.
Right. And also there's another mission that's a couple other missions that are happening now. One to plan to go to Psyche, which is a presumably M-class, maybe metal-rich asteroid. And one of the scientists there has been associated with the Vatican Observatory. This is Minnie Wadwa is part of that, as I recall. And she's at Arizona State, but she is also the lead instructor of one of our summer schools. So it's a small field. We all know each other. Even when we're not actually on the spacecraft mission, we're part of the community that gets to kibitz and gossip.
And speaking of being part of the community, you mentioned earlier your role on a review panel, and that is something that we're in a peculiar position for, because on review panels, they really want experts and people who kind of know something about what's being proposed. Unfortunately, the people who know something about what's being proposed are either on the proposal or are competitors with people who are on the proposal. And so you have a lot of conflict of interest, potentially. So it's hard to find people who don't have a stake in the game as far as that goes, but who also know something about what's going on. And that's a peculiar role that we Jesuits at the observatory can fill in oftentimes.
Because we're not, competing for the same money. And actually, to end the story of Paul Steffes on Juno, he's actually one of the mission scientists now, because the person who had been doing that job had to leave, and he was the most qualified person to take over.
But just to reiterate, essentially planetary science is this global village, and we all get together a couple of times a year in the pre-COVID times to talk about our mutual interests. And so literally everybody knows everybody else, and we keep in contact constantly because the goal here is to advance the science. And so even if you're not involved in the mission, what you want to do is you want to make sure that the best outcome is what happens. So you try to support it whenever you can.
A lot of people look at me as a planetary scientist at the Vatican, and they wonder how I can deal with, working with a giant bureaucracy that's full of infighting and full of personalities and full of people who are more interested in their own careers. And I tell them, for all you can say that about NASA, nonetheless, they're the only group that got us to the moon.
Well, also, you can say that about almost any large bureaucracy, like the University of Central Florida, which I have to deal with all the time. And they're not so bad. But the point is that they give us this opportunity to do something that I would do for free if I could, because I enjoy it so much.
And I think that joy is the place where I want to end this. Why do we do this at the end of the day? Is Lucy going to make anybody rich? No. Is it going to make us handsome and virile? No. Is it going to give us power? No. But it is going to give us the thing that we live for. That sense of joy, that sense of feeding our own curiosity. I read someplace that we don't live by bread alone. It's literally true. If we starve the things that makes us want to explore, then we're starving our humanity. And so I got to thank you, Dan, for being part of this, and also for helping us explore the universe. And thanks, Bob, for sacrificing your time for a mission that is going to eat up your time for most of your life, it sounds like.
I will say one more thing. Thank you very much for the opportunity to get into meteorite physical properties, because when we started this, it wasn't a field. And very smart people came up to each of us separately and said, "You're wasting your time. Don't do this. There's nothing to find." And the problem is that they were just dead wrong.
I don't know if we mentioned it, but Dan was my thesis advisor when I did my PhD at the University of Central Florida. So between the guy getting me into meteorite studies and Dan leading me through my PhD in the same field, I have to blame the both of you for being where I am today. So thank you.
Okay, and that's a wrap for this podcast. I'd like to thank our guests, Dr. Daniel Britt from the University of Central Florida, and brothers Bob Macke and Guy Consolmagno from the Vatican Observatory. You can listen to our other podcasts at the Vatican Observatory website. Clear skies, everyone.